So we've got our coupled differential equation. We know the eigenvalues are -1 plus or minus 2i. And so we're going to use the sequence way on the calculator to do this.
Wait, was that eigenvalue given?
They found it, but
Yes.
in the answer, yes, it's given in the answer. I'm not taking the time to find it because you should be able to find eigenvalues by this point. Like, it's just putting it in a quadratic and solving the quadratic. And we did a bunch of those yesterday, so I need this idea, xn plus 1 equals xn plus. I just use for the purpose of these 0.1 because your calculator can generate it pretty quick. X prime n, and then I need to do the same thing with y. So I go to my calculator. I add a graph. I get rid of this circle at the bottom because it's not helpful. I take my graph and I make it a sequence, right? And we start with our basic sequence. So it's un plus 1 always. It's always then u1 n is the xn part plus 0.1 times dx dt, which is -3 times x is u1n. Any y minus 4, y is going to be u2n. And I close my parentheses. It should have given me an initial value in the problem, which I need to pay attention to that. Okay. It gave me these initial values. So my initial term for the x is 6. Let's just go 0 to 99. I don't know how many I need to go. 40 is usually enough, but we'll let 99 go because it can do all of it for me pretty quickly. I don't want to go like 1,000. That'll be too many. So do you see how I'm just turning my x's into u1n's and my y's into u2n's? And so I've still got that on the side here. u2n plus 1, u2, u2n plus 0.1. Y prime is 2x. I should put a times in there. I should hit the times button. Let's parentheses. Initial term, initial y is 2. And I'm going again, we'll just go 0 to 99. I'm going to hit tab again and turn these off because this is not, that's just those individually. It's not them put together. Okay. And my phase plot, I want them put together. That makes sense? So then now that I've turned them off and it's not showing, this is where I go to the sequence custom u1 of n, u2 of n, and I did 0 to 99 here. And we see our nice plot. That makes sense. We do need to make sure we start. So all it's going to ask you is to do is sketch this thing. You do know it's spiraling in. You know it starts at 6, 2. What's your sketch look like? That.
Or just like memorizing how to do it on my code.
So it's the sequence thing. And you're doing this. This formula is the same for X and Y for everything with Euler's method. I'm choosing a step size of 0.1 because I don't feel like doing more. I guess I think I'm glad I did the 99. It might have cut off short right before getting to 0, 0. But I just did enough of them. You turn off the originals so they're not distracting, and then it's that sequence custom. You're gonna have to practice that. I promise you there's well, there's 2 of these on the test where you're gonna make the sketch. Graph entry edit, sequence, and then you go to custom. And then what do you put in?
Yeah.
So you're just making X your U1 and Y your U2. And then the bottom thing should be the same as what you did in the others. Okay. So all it's doing is taking those 2 sequences, making them coordinates of each other instead of random. Okay. You're gonna need to practice that. I will absolutely help you with questions when you get stuck on, wait, where did I enter this correctly?